There is a parable in an ancient Chinese manuscript about a man being chased by a tiger. In his fear, the unfortunate man ran to the edge of a cliff and plunged down. 2 other tigers awaited him in the gorge. In the final moments before his fall, the man grabbed a thin branch and hovered above the abyss for a split second. Suddenly, he noticed a flower growing in the cleft of the rock. "What beauty!" exclaimed the man as he descended, now free of fear. What provided comfort to the man before his imminent doom? What offered him solace? The ancient Chinese answered, beauty. This brings us to the focus of today's study, the phenomenon of beauty, or perhaps not, the noumenon of beauty. Here, we tread on very uncertain ground. In philosophy, the noumenon refers to the realm of intelligible entities, that is, things that exist beyond our sensory perception. In other words, it is what can be thought but not perceived by the senses. On the other hand, a phenomenon is an object of the sensory world. That is, it is presented to us through sensations. Accordingly, there are 2 modes of cognition, sensory and rational. Suppose substance, as the foundation of the world, can only be conceived mentally. This is the nominal way of cognition. In contrast, ice cream can be seen, touched, and tasted, making it a subject of phenomenal cognition. The significance and complexity of the question, what is beauty, lie in our need to recognize beauty either as a purely irrational phenomenon or as a rational one. I will take this further and pose a more challenging question. Is beauty objective? Can we derive a formula for beauty or find some absolute ratio in our universe? Regardless, the influence of the power of beauty on the modern world is undeniable. It is an ancient mechanism within our consciousness that compels us to structure, analyze, and reorganize everything within our reach. People have long been aware of the profound possibilities of beauty. They drew, combined, and decorated primitive tools, household items, clothes, and weapons with simple and entirely impractical ornaments. This is how one of the most ancient forms of labor emerged. Art, aimed at expressing that elusive beauty. Not only that, but since time immemorial, some ephemeral force has compelled various living beings to transform the matter around them. However, humans have been more successful in this endeavor than any other species. The results are evident before our very eyes. The outcomes are truly tremendous. Yet, this vast industry of transforming beauty gained momentum gradually. Man's first tool was the stone knife, which was in use before the existence of language. But what can we observe here? The knife is symmetrical. It makes no sense from a functional point of view. A saber-toothed tiger can be killed with an asymmetrically sharpened stone. American-New Zealand philosopher of art Denis Dutton states, "People have sharpened stones and given them symmetry for aesthetic reasons." Beauty occupies an important place in our society. In a general sense, the beauty industry permeates the fabric of our entire civilization. However, to understand the mystery of beauty, to comprehend the nature and mechanism of this special category of perception, would seem to be almost impossible. Is beauty a property of an object or a peculiarity of perception? Is beauty an inherent property of an object itself, or is it determined by the observer's perception? This question has been debated since antiquity, and we will endeavor to address it. In developing a viable theory of beauty, the aforementioned philosopher Denis Dutton attempts to elucidate the experience of perceiving beauty from the perspectives of philosophy and psychology. Dutton's objective is to explore the nature of this mechanism within our consciousness. Beauty, as a subject of study, is akin to a slippery fish, perpetually evading our grasp. The subject of our study is exceedingly abstract and complex, partly because we attribute the label beautiful to vastly different entities. Consider this: something can be beautiful in the form of a person, a text, a story, music, a painting, a pattern, the cosmos, anything man-made or natural. Beginning with nature, we will delve into concepts generated by our minds. Naturally, many of you might think, I know what beauty is. Beauty is subjective. What I consider beautiful is beauty. Beauty arises from cultural differences in perception. People in various countries experience beauty differently. But does this hold true upon closer examination? Yes, superficially, the manifestations of what is considered attractive, desirable, and beautiful may vary from one culture to another. However, the appreciation of beauty on a fundamental, behavioral level in both nature and art transcends geographical boundaries. Beethoven's music or Chekhov's plays are appreciated in Japan. Japanese anime is cherished in Germany and Russia. Inca sculptures are regarded as the gems of British museum collections. Shakespeare's plays have been translated into every language worldwide. Similarly, American jazz and cinema are universally appreciated. It is unwise to deny the existence of specific cross-cultural aesthetic values. So, how can we explain this ubiquity and attempt to reconstruct the path of our development as life forms? We need to reflect on our modern preferences and tastes and elucidate how they became ingrained in our minds. Throughout evolution, we have been influenced both by the prehistoric natural conditions of the Pleistocene epoch, during which intelligent humans ultimately developed, and by the social conditions in which we have existed and continue to exist. Preserved traces of prehistoric human activity, such as fossils and rock art, can also aid us in reconstructing aesthetic perspectives. Additionally, we must consider all that we know about the aesthetic preferences of isolated tribes of hunters and gatherers, which in some parts of the world still persist today. Sexual beauty is most often associated with health, and this association seems logical. However, how can we explain our aesthetic attachment to more abstract entities, like flowers or music? Is the sensation of their beauty somehow linked to the search for food or a sexual partner? If we apply the simplistic logic of the evolutionary approach, our common ancestor consumed flowers, but then, for some reason, ceased to do so. This has left an evolutionary vestige deep within our psyche, an attachment to a long-standing food rations, and this evolutionary vestige does not let go of us, so much so that the perfume industry is thriving. Perfume companies are extracting millions from consumers by marketing fragrances with various floral scents. To be honest, the appearance of what ancient humans might have eaten, perhaps only brightly colored berries and fruits, does not aesthetically please us today. People do not exchange bouquets of meat. The existential importance of survival for our civilization does not render an object beautiful. Does spending hours at a classical music concert contribute to successful food acquisition or reproduction? From the perspective of the survival of the fittest theory, such behavior might seem detrimental and utterly pointless, a waste of valuable time that could be spent on social competition. What is the biological significance of enjoying music? Clearly, at this stage, the answer to the question, "What is beauty?" continues to elude us. The question, "Why do we like both the sight and the smell of flowers?" remains, of course, a mystery to us. Personally, I am almost certain that such preferences, not only aesthetic preferences for colors, but also, for example, for music and especially for certain features of a beautiful human face, are deep psychological effects that evoke a sense of aesthetic pleasure. They are byproducts of something else. After all, the very nature of the pleasure that arises during aesthetic experiences differs sharply from all other kinds of pleasure. This suggests that it is not a mere mistake. Indeed, our brains contain specialized centers responsible for the aesthetic enjoyment of certain objects in the surrounding world. Therefore, any pronounced biological trait or aesthetic preference should be beneficial within the framework of the modern theory of evolution. But what if Dennis Dutton and other evolutionists are wrong, and evolution cannot adequately explain the sense of beauty? In this issue, you will learn how the peacock's tail taught us to love art, why our consciousness perceives the golden ratio and fractals everywhere, and what neuroculture is and why it is becoming akin to a religion. What laws govern our sense of beauty? Is there anything objectively beautiful? And how can we encapsulate the entire universe into a single formula? Get ready, the exciting part hasn't even started yet. If you're interested in what I'm doing and want to support my work, please give me a like, leave your comments, and subscribe. Today, I've got something special for you. I've partnered with Fioboc, a premium men's clothing brand that's been turning heads lately. They've sent me 3 of their top products to try out: the Model Blend Long Sleeve Tee, the Gentle Knit Crew Neck Sweater, and the Mauve Masters Jeans. Let's dive right in. First up is the Model Blend Long Sleeve Tee. Let me tell you, this isn't just any long sleeve tee. It's made from a luxurious blend of modal, cotton, and spandex. Modal is known for its silky softness and breathability. And combined with cotton, it creates a fabric that's incredibly comfortable and durable. The spandex adds just the right amount of stretch. I've been wearing this tee for a few days now, and it's quickly become a staple in my wardrobe. The fit is perfect, not too tight, not too loose, and it drapes nicely over the body. Whether I'm lounging at home or heading out for a casual meetup, this tee has got me covered. Plus, it's versatile enough to layer under a jacket or wear on its own. The craftsmanship is top-notch with reinforced stitching and a smooth finish. Next, we have the gentle knit crew neck sweater. As soon as I put this on, I could feel the quality. It's crafted from a premium knit fabric that's both soft and warm without feeling heavy. Perfect for those cooler days ahead. What I love about this sweater is its timeless design. The crew neck is classic, and the knit pattern adds a subtle texture that elevates any outfit. I've paired it with jeans for a casual look and even dressed it up with slacks for a more formal occasion. The attention to detail is evident. The cuffs and hem are neatly finished, and the sweater holds its shape even after multiple wears. It's not just stylish, it's built to last. Finally, let's talk about the Move Masters jeans. Finding a pair of jeans that combines comfort, style, and durability can be a challenge. But Fioboc has nailed it with these. These jeans are made with a unique fabric blend that offers flexibility without sacrificing the ruggedness you expect from denim. They've incorporated elastane into the mix, giving you that extra stretch. So whether you're sitting at your desk, running errands, or even doing a quick workout, these jeans move with you. The fit is modern and sleek, and the wash is versatile enough to match with almost any top. The stitching is strong, and the pockets are functional, big enough to hold your essentials. Overall, I'm thoroughly impressed with Fioboc's offerings. The model blend long sleeve tee, the gentle knit crew neck sweater, and the Move Masters jeans have exceeded my expectations in terms of comfort, quality, and style. If you're looking to upgrade your wardrobe with pieces that are both stylish and comfortable, I highly recommend checking them out. And here's the best part. Fioboc is offering an exclusive deal for my viewers. Click the link in the description or use my code MW20 at checkout to get a special discount on your purchase. Don't miss out on this opportunity to elevate your style. In our minds, beauty is a universal phenomenon. For example, we all find bright colors beautiful. We've all heard that the human brain prefers proportions and fractal objects. However, all these aspects and attributes of beauty have changed throughout history. What if it turns out that much of beauty does not depend heavily on the course of evolution? Suddenly, everything else becomes just vast, multi-level cultural superstructures. To understand the nature of beauty, we'll delve into both scientific and philosophical contexts. In ancient Greece, beauty did not have an autonomous status. One could even say that the Greeks, at least until the time of Pericles, had no real aesthetics or theory of beauty. It is no coincidence that beauty was always associated with other qualities. For example, when asked about the criteria for judging beauty, the Delphic oracle answered, "The most beautiful is the most right." At the turn of the 7th and 6th centuries BC, ancient Greek philosophers such as Thales, Anaximander, and Anaximenes began to discuss the origin of all things. They sought to define the universe as a unified whole, organized and governed by one and only one law. This means, among other things, that the world was conceived as form. The Greeks clearly identified form with beauty. However, the first to clearly express all this in his writings and to intertwine cosmology, mathematics, natural science, and aesthetics into a single framework was Pythagoras. During his wanderings, likely having come into contact with Egyptian mathematics, Pythagoras first articulated the statement that the beginning of all things is number. With Pythagoras, the aesthetic mathematical perception of the world originated. All things exist because they reflect order, and they are ordered because they realize mathematical laws, which are both conditions of existence and beauty. The Pythagoreans were the first to investigate the numerical relationships that govern musical sounds, such as the proportions underlying intervals and the ratio of string length to pitch. The concept of musical harmony is closely intertwined with principles aimed at creating beauty. Undoubtedly, for the early Pythagoreans, harmony involved the opposition of limit and infinity, singularity and multiplicity, right and left, male and female, square and rectangle, straight and curve, and so forth. For them, contrast and symmetry were paramount. The idea of proportion permeated antiquity and extended into the Middle Ages. During the Middle Ages, however, the mathematics of proportions were rarely applied to the assessment or depiction of the human body. This partial abandonment of traditional practices can be explained by the shift from bodily beauty to spiritual beauty. Naturally, the mature Middle Ages still perceived the human body as a marvel. An example of this shift is found in the works of Thomas Aquinas. Nonetheless, Pythagorean criteria based on proportion were also employed to define moral beauty, such as in the symbolism of Homo quadratus, literally a square man, which Aristotle used as a metaphor for reason and balance. Subsequently, this symbol was transformed into the concept of the Vitruvian man. Medieval culture evolved from the Platonic idea that the world was perceived as a large living being, akin to a man. In other words, the cosmos was envisioned as a large man and man as a small cosmos. Our current understanding of the universe's complexity and the brain generally supports this notion. This is where the so-called square man theory originated, in which number, the principle of the universe, acquires symbolic meaning based on numerous numerical correspondences that are simultaneously aesthetic. In art, it should mimic nature, which was divided into 4 parts. The number 4 became a reference point and key. The sides of the world, the main winds, the phases of the moon, and the seasons all number 4. Building upon the number 4, the tetrahedron of fire is described in Plato's Timaeus, and the name Adam consists of 4 letters. As Vitruvius taught, 4 is the number of man, with the length of the arm span corresponding to height, thereby establishing the parameters of the ideal square. The Middle Ages firmly believed that everything in the universe was endowed with supernatural meaning, and thus colors acquired positive or negative connotations. Society was divided into the rich and powerful, the poor and disadvantaged. Although this division is not unique to medieval society, in antiquity, and particularly during the Middle Ages, the disparity between rich and poor was more pronounced than in most modern countries. To demonstrate their power, nobles adorned themselves with gold, jewels, and bright clothing, favoring the most expensive colors. The production of artificial dyes from mineral or vegetable sources was complex, making bright colors a luxury. In contrast, the poor wore dull and modest garments. At the same time, the underprivileged could only enjoy nature, the sky, sunlight, moonlight, and flowers, thereby associating their instinctive perception of beauty with the variety of colors presented by nature. During the Enlightenment, where reason was paramount, a countervailing force emerged: Romanticism. Driven by the idea of the sublime, Pseudo-Longinus first articulated this concept around the 2nd century. However, it was not until the mid-18th century that the concept of the sublime gained special significance. Today, the idea of the sublime is associated not primarily with the experience of art, but with the experience of observing nature. In this context, preference is given to the formless, the solitary, the painful, and the terrible. The emphasis, however, is placed on the process of purification, catharsis, through which the observer is freed from passions that, in themselves, provide no pleasure. In the second half of the 18th century, there was an increasing appreciation of Gothic architecture, which by classical standards can only be described as disproportionate and irregular. This craving for the irregular and the non-ideal led to a new way of perceiving ruins. Ruins came to be valued precisely for their fragmentation, the traces left by inexorable time, and the wild plants that surrounded them. One of the characteristic features of 20th century art is the constant focus on everyday objects in an era dominated by the pervasive market. The reduction of any object to a commodity and the gradual disappearance of use value in a world governed solely by exchange value radically changed the nature of everyday objects. An object must be useful, practical, relatively economical, conform to common tastes, and be mass-produced. This means that the qualitative aspects of beauty are increasingly being replaced by quantitative aspects in the flow of goods. The popularity of an object is determined by its functionality, and both functionality and popularity increase as the number of objects produced from the original model rises. Consequently, the object loses the uniqueness that defined its beauty and meaning. The new beauty is reproducible and, moreover, temporary and short-lived. It must prepare the consumer for the rapid replacement of the object due to wear and tear or obsolescence, ensuring that the production, distribution, and consumption chain is uninterrupted. The perception of beauty changes not only historically and temporally, but also territorially. When we consider the history of beauty in this way, we are, of course, creating a highly conventional narrative, as the correct approach would be to examine the transformation of culture and worldviews within the context of a particular country or even a specific people. However, doing so would be too cumbersome. For our purposes, it is more important to recognize that seemingly fundamental concepts of beauty are changeable and not fundamental at all. The key realization is that there is no single perception of beauty. Everything is highly plastic. The very perception of beauty has taken on different forms. Thus, the perception of proportions follows its own trajectory. The perception of color has undergone its own transformations, and even the ideal forms of the female or male body can be radically different depending on the era or country. In any culture, alongside its own concept of the beautiful, there is always its own idea of the ugly. Although it is usually difficult to ascertain from archaeological findings whether a particular image was considered ugly, modern observers may perceive the masks of other civilizations as horrific and ugly creatures. In contrast, for the bearers of those cultures, they may have been considered beautiful. There exists ugliness that causes us disgust in nature, but becomes acceptable and even pleasant in art, which perfectly conveys and denounces the ugliness understood in both physical and spiritual senses. But where is the limit beyond which the beautiful depiction of the ugly and monstrous begins to endow it with attractive power? In this context, one cannot help but recall the uncanny valley effect, formulated in 1970 by Japanese roboticist Masahiro Mori. On his graph, Mori illustrated the relationship between the humanoidness of an object and the level of sympathy for it. According to this theory, the closer the appearance of an object is to that of a human, the lower the level of sympathy it elicits. Objects that closely resemble a human face but behave differently or possess inanimate, irrational features tend to evoke fear in us, and this is understandable. We are frightened by something whose behavior we cannot predict, yet we perceive the potential for some kind of action. This is similar to the fear we feel for predatory or simply large animals when we encounter them. But why are we attracted to the dangerous, the unknown, the things that can literally cut short our lives? Why does the image of being with a pack of whales in the open ocean at night evoke both fear and, at the same time, delight and curiosity? Here, it is interesting to consider the natural history written by Pliny the Elder in the 70s of the 1st century, the most extensive encyclopedia of all knowledge at that time. These texts feature outlandish people and animals, which later migrated into various medieval encyclopedias, and even into the accounts of later travelers. Medieval culture does not question whether these monsters are beautiful. It is fascinated by the outlandish. This fascination is merely the form in which what would later be called exoticism was expressed at that time. Humans enjoy exploring the world in different ways, but exploration can only occur if one is not directly threatened. The image of whales appears beautiful until one finds oneself within it, alone in the open ocean with enormous creatures. In such a situation, a person will likely experience genuine fear. Similarly, though to a lesser extent, we experience fear when looking at a scary painting or watching a horror movie. However, this fear only arises if we immerse ourselves in the situation, sympathize with the characters, or vividly visualize the ugliness. If a person views the picture, movie, or monster from a distance, as an observer looking into a nightmare, they will experience delight and interest. They will feel the beauty of the terrible and the ugly. The most significant contribution to the study of the nature of beauty was not made by an art historian, a postmodern theorist, or an authoritative art critic. No, it was a specialist in crayfish, worms, and bird beaks. You know who I'm talking about. I'm referring to Charles Darwin. As you know, there are two main evolutionary mechanisms: the selective fixation of random changes and the preservation of major features of anatomy and psychology. Natural selection explains many of our deep-seated fears and aversions, such as the repulsive odor of rotting meat, fear of snakes, or fear of heights. The same mechanism explains pleasure, sexual pleasure, cravings for sweet, fatty, and protein-rich foods, which in turn explains many sexual and food preferences, from chocolate to barbecue wings. The second most important mechanism of evolution is sexual selection. Its manifestations are highly diverse. The magnificent peacock's tail is one of the most striking examples. It did not arise as an advantage in the struggle for survival. In fact, it is a burdensome evolutionary byproduct, a mistake. The peacock's tail exists due to the preferences in the choice of sexual partners made by female peacocks. This is quite natural. Often, the evolutionary direction is set by females, as they are the ones who most frequently decide whether to enter into a relationship or not. Even Darwin pondered the nature of the peacock's tail and concluded that the female peacock finds the male's tail beautiful. Thus, strictly adhering to this theory, we conclude that beauty remains one of the evolutionary adaptations that drive and sustain sexual interest, fascination, and sometimes even obsession between individuals. But this is not the complete answer. The question is transformative. How, then, do female peacocks experience beauty? There seems to be no concept of beauty in nature because it would simply have no meaning. However, there is another category filled with practical significance: sexual dimorphism. Sexual dimorphism refers to the anatomical differences between males and females of the same biological species, such as horns, coloration, teeth, hair cover, size, and so forth. Sexual dimorphism allows animals to determine the gender of other individuals. Contrary to popular belief, the degree of expression of sexual dimorphism affects the choice of a partner to a lesser extent. The less parents participate in the life of their offspring, the more strongly expressed the secondary sexual characteristics become, and vice versa. The peacock's tail is the most obvious example of a product of the mechanism of sexual selection. It is large, beautiful, and noticeable. It is present only in males and serves to attract females who see in its owner an effective successor for the family. However, it is important to acknowledge that females are attracted not solely by visual beauty, although it plays a role, but also by the indication that the owner of such a large tail must be powerful and resilient enough to carry the extra weight of the feathers. This concept is known as the handicap principle. The handicap principle posits that certain traits observed in males of some animal species, which are detrimental to survival, serve as demonstrations of genetic health and quality. The peacock's tail exemplifies this principle in its purest form. Despite the fact that carrying a large tail makes the male slower, clumsier, and more vulnerable to predators, females perceive it as advantageous. The reasoning is that a male who has survived despite the handicap must possess the strength and agility necessary to protect himself from predators. Therefore, selecting such a male to pass on his genes to offspring is beneficial. Clear example of a handicap in humans is a man's beard. According to some evolutionary theorists, a lush beard can harbor a significant amount of potentially pathogenic bacteria, which could be lethal. If a man with a beard does not succumb to infection, it suggests that he possesses excellent health. Additionally, a beard visually enhances the size of the jaw, contributing to an intimidating appearance. The preliminary conclusion is that sexual dimorphism and biological handicaps gradually compel living beings not only to seek partners, but also to compete in ways that impress potential mates, forcing them to attract attention through increasingly abstract means. It appears that sexual dimorphism and the handicap principle initiated the chain reaction leading to the development of an aesthetic worldview. Coupled with the advancement of the brain, this process has paved the way for the emergence and evolution of culture. All cultures are mortal, and so are religions, stated philosopher George Steiner in 1999 at a conference celebrating the 30th anniversary of the Piaget Institute in Portugal. Currently, we are experiencing a transition period in which Christianity and other religions may decline. But what will fill that void? Recalling Steiner's words, Spanish neurophysiologist and University of Madrid professor Francisca Mora believes that knowledge about the brain will occupy this space. The rapid accumulation of information regarding how our brains function is transforming our perspectives on many philosophical, ethical, legal, economic, religious, and artistic questions. These profound changes are fostering the emergence of various interdisciplinary sciences prefixed with neuro, such as neuroeconomics, neurophilosophy, and neuroethics. There is even a field known as neurotheology. The entirety of these new scientific disciplines has come to be referred to as neuroculture. Neuroculture encompasses a variety of distinct fields. Proponents of this idea argue that everything ever created by humans makes sense only when understood through the workings of our onboard computer, the brain. According to Mora, nothing in the human world happens or exists that has not been processed through the sieve called the brain. Many may perceive neuroculture as a departure from understanding the spiritual essence of human beings. However, for many others, it represents an approximation to the truth, a new conception of humanity, grounded in scientific evidence and critical, analytical thinking. Why is this context necessary? One of the sciences related to neuroculture is neuroaesthetics. This emerging field seeks to explain how the perception of beauty is related to brain activity and how that activity is connected to human evolution. The emergence of neuroaesthetics was driven by the advent of modern technology that allows us to observe human physiological responses in real time. One of the pioneers in studying the perception of beauty was British neuroscientist Professor Semer Zicki from University College London. He published numerous scientific papers on this topic and, in 1999, released the book Inner Vision, An Exploration of Art and the Brain, in which the term neuroaesthetics was introduced. Zicki summarized his research in the field of neuroaesthetics during a TED Talk in 2012. In his experiments, he and his team asked random volunteers to rate various paintings and musical excerpts on a scale from 1 to 9. Participants were asked to listen to, for example, an excerpt from Gustav Mahler's Fifth Symphony, while the scientists monitored their brain activity using functional magnetic resonance imaging. The scientists hypothesized that there might be a single brain region or several regions that activate when perceiving beautiful works of art, whether visual or auditory. They discovered that, although the perception of beautiful images and music activated entirely different parts of the brain, one region, the medial orbitofrontal cortex, was active in both cases. Moreover, the more participants liked the music or picture, the stronger the activity in this area. Zicki suggested that the medial orbitofrontal cortex is responsible for the perception of beauty, regardless of whether we are looking at something beautiful or listening to it. However, a limitation of Zicki's study was that only 21 individuals participated. Other scientists hesitate to claim that there is a single center of beauty in the brain. For example, Francisca Mora discusses creativity alongside the perception of beauty, stating, "Creativity, just like ethics, the beauty of decision-making, or the ability to think or draw conclusions, is not located in a specific area of the brain. To create is to be able to inspire, to think, to learn, to memorize, to imagine. Behind all of this are brain functions whose processing is distributed across different areas, neural systems, and specific networks." The team from Tsinghua University concluded that the theory of a single beauty center might be considered disproven and commented on this in the popular science journal Scientific American. They suggested that such a center could exist but may not have been detected due to methodological limitations. In any case, a single study is insufficient to definitively resolve such a complex and profound issue. This is often the case with the brain. Researchers attempt to locate specific phenomena, like consciousness, but no amount of research can pinpoint anything concrete. Processes are remarkably distributed across different regions. Consequently, the brain and consciousness remain a black box to researchers. Nevertheless, some scientists endeavor to pierce the veil of ignorance through theoretical exploration. One of the most renowned neuroaesthetic theories is proposed by the eminent Indian neuroscientist Vilayanar Ramachandran. In his book, The Telltale Brain, Ramachandran identified 9 laws of aesthetics from the perspective of the brain. Please trust that this type of analysis does not diminish the sublime spiritual dimensions of art, just as the brain's physiological breakdown of sexuality does not undermine the magic of romantic love. The scientist then enumerates the laws themselves, examining each in terms of the benefits it provides for our survival. Quoting the Russian-American geneticist Theodosius Dobzhansky, Ramachandran explains, "Everything in biology makes sense only in the light of evolution." The first law of our perception is grouping. Artists often select a single color scheme for their paintings for a reason. Similarly, a clothing store consultant advising us to add a red scarf to red pants does so for a purpose. Grouping colors brings us pleasure. For tens of thousands of years, humans lived not in urban environments, but in forests and savannas, where one of the most valuable skills was the ability to distinguish and notice objects amidst the foliage. To avoid them, hide, chase them, eat them, and hide again. If our ancestors observed a few yellow patches behind the foliage, Ramachandran writes, their brains interpreted, what is the probability that all these fragments of the same color are pure chance? Well, 0, of course. So perhaps they belong to the same object. Thousands of years later, the saleswoman in the store and the artist in the studio unconsciously follow the same ancient aesthetic principle ingrained within us. The second law of our perception is exaggeration. The brain responds to exaggerated objects. In ancient Sanskrit texts on aesthetics, scholars often use the term rasa, which can be roughly translated as grasping the very essence. Similarly, talented artists extract the main characteristics of the objects they depict and exaggerate them. This law is most clearly illustrated in caricatures. A caricaturist identifies the primary features of a person's face and amplifies them beyond the average of all other faces. The resulting image resembles you more than you actually are. According to Ramachandran, artists who create abstract paintings rely on the representational elements of our perception. Without the mind's ability to capture the very essence of objects, the genius of Van Gogh and Claude Monet would not have emerged. Law number 3, contrast. Contrast can manifest in various forms, light and shadow, color or material, and even in more abstract conceptual opposites. One reason this phenomenon captures our attention, Ramachandran believes, is that our ancestors were trained to distinguish brightly colored fruits against a background of leaves at dusk or in the distance. While grouping allows us to identify bright spots over broader distances, recognizing contrast involves comparing adjacent areas. Today, we have adapted contrast for purposes far removed from survival needs. For instance, when choosing clothes, we might select a scarlet scarf to match red pants, but we wouldn't pair it with a ruby shirt. However, a scarlet scarf with blue clothing creates a contrasting and therefore beautiful combination. Modern artists also employ more abstract forms of contrast. Tara Donovan, for example, used texture contrast to create a large cube covered with tiny metal needles, making its surface resemble fur. Typically, metal cubes have smooth surfaces, but in this case, they appear as if they are covered with fur. This conceptual contrast is the key point. The fourth law, isolation. The principle of isolation is observed, for example, in sketches where the artist emphasizes only one source of information and eliminates others. Sometimes, sketches by Leonardo da Vinci or Auguste Rodin produce a greater effect than photographs. Biologically, this is because the brain has a limit to its attention and sometimes prefers to perceive only form. Even though our brain contains approximately 100 billion nerve cells, only a small group can be active at any given time. The principle of isolation allows the artist to focus your attention on the most important element by providing minimal information. Ramachandran's fifth, sixth, and seventh laws are paradoxical. On one hand, absolute symmetry is unnatural to us, as it is almost never found in nature. Organic asymmetry is certainly familiar to us. On the other hand, both our brain and consciousness are constantly striving for order. This desire, says Ramachandran, probably reflects our visual system's deep need for economy in processing visual signals. Crookedly hanging painting or an uneven stack of books can be irritating for this very reason. Our brains require predictability. This craving for predictability can explain our love of visual repetition and rhythms, such as the repetitive plant patterns on Persian rugs and rhythmic music. In addition to orderliness, we are attracted to symmetry. One theory explains our love of symmetry by noting that in nature, humans are surrounded by asymmetrical objects like trees, fallen trunks, mountains, and clouds. However, the truly important objects to humans, prey, predators, mates, and both females and males, are always symmetrical. A second theory presents a different perspective. In one of the experiments that Ramachandran mentions, student subjects were shown faces with varying degrees of symmetry. The most symmetrical faces were labeled the most attractive by the students. We owe our aversion to asymmetry to parasites. If infected while still in the womb, parasites can cause subtle facial asymmetries. Since parasites pose a significant threat to survival, we are highly adept at recognizing even slight asymmetries. This is why symmetrical features are indicators of health for us. According to the eighth principle of perception, mystery, sometimes something can become more attractive by being less visible or less recognizable. An example would be a face with loose hair falling over it or smudged lilies in a Monet painting. Biologically, this principle is explained by our enjoyment of solving puzzles. Every time we find a partial match to our perceptions in a perceived object, dopamine is produced in the brain. This signal is sent to the limbic reward structures, which in turn trigger a search for additional dopamine until the final object or scene comes together. The final ninth law of beauty perception is metaphor. Metaphor, as a hidden comparison, functions similarly to a riddle for our brain. Deciphering a metaphor produces dopamine. We often perceive simple solutions to problems as beautiful because our brains favor simplicity and, at the most fundamental level, appreciate the principle of Occam's razor. Given equal explanations, we prefer the simplest one, cutting away all unnecessary elements. These are the 9 laws of neuroaesthetics. However, the noble application of this science in practice does not validate the new scientific field in the eyes of its critics. The biological explanations of beauty that neuroaesthetics offers seem simplistic to them. One of the most vocal critics of the new science is Alva No, a professor and philosopher at the University of California, Berkeley. In his work Art and the Limits of Neuroscience, No argues that the idea that humans are merely a collection of cells and molecules is not a discovery of neurobiology. The assumption that we are our brains was proposed by neuroscientist Francis Crick in the 20th century, whom No describes as astonished by this hypothesis. However, what is truly striking about this supposedly startling hypothesis is how little is actually startling about it. The concept that there is something inside us that feels and thinks for us is as ancient as humanity itself. This something was once referred to as the soul, and now it is called the brain. That is the fundamental difference. The soul is an idealistic concept, whereas the brain is materialistic. Any discussion about the soul, consciousness, and the brain becomes a clash between older idealist and materialist narratives. Essentially, the perception of anything is accompanied by 2 basic factors: constancy and abstraction. Permanence refers to the mind's ability to hold the image of something constant regardless of the angle of view, movement, lighting, and other factors. For example, if there is a chair in a room, we recognize it no matter its orientation. Moreover, when you hear the word chair, you immediately visualize the room with the chair, even though it does not exist outside your consciousness. Abstraction, on the other hand, means that consciousness, when observing any image, constructs a hierarchy of what is depicted. This process is akin to a highly advanced face detector on your phone, where the most important features are identified while the rest is blurred out. Thus, when a stranger with an axe stands in front of you, your brain prioritizes your attention to the axe, but not necessarily to the color of his shoes. Beauty, however, reverses these processes. Artists do not merely reproduce images, they interpret them in ways that disrupt habitual patterns of perception. Whether it's a window, a painting, or a screen, the brain perceives them in fundamentally different ways. We know for a fact that the brain essentially perceives everything as reality. For the brain, there is no unreal. This applies equally to figurative realistic and abstract paintings. Although the brain perceives them very differently, it often takes much longer to process an abstract painting. However, once processed, the emotional effect is often much stronger than that of figurative paintings. The question of beauty is always asked within one stratum of being, be it in sound, visual, or aromatic forms, but it is resolved in another, philosophically. Yet we always feel the presence of beauty. Beingness's ontological indeterminacy in some way protects beauty from simple explanations based on mechanical brain reactions that can describe all the minute aspects of this experience. Beauty cannot be measured, it can only be experienced. Having explored the evolutionary approach to explaining beauty, we will not stop here. We will go further and attempt to understand the phenomenon of beauty by posing another eternal question. What is man? From the perspective of our cultural present, we are slaves to the discourse that permeates our brains from childhood. We are prisoners of a set of conventions and categories. Is man simply a slave to circumstance, forced to endure the dictatorship of genes? A dictatorship that, through sexual dimorphism, controls our sense of beauty. Ultimately, any reflection on the meaning of human life boils down to this question. Does man have free will? Is this slave of genes and culture, of nature and society, capable of creating something new, something of his or her own? However, those who think along these lines are not framing the question correctly. Free will is the freedom to do what one wills. But what does it mean to do what one wants to do? If we momentarily set aside the individual, any physical system by definition does what it wants to do. That is, what it strives to do. Meteorite wants to hit the ground, so it falls. Bacterium seeks a food source. Similarly, a human being seeks companionship. The question of free will is not about whether humans are free in their actions. Everything in the world is, in principle, free in its actions. The real question is, what constitutes one's actions? When we ask whether human wills are free, we are essentially trying to determine whether what we do, what we love, and what we perceive as beautiful truly belongs to us. Are the desires of my body controlled by me or by something else, genes or cultural attitudes? But what is me? Who is this being that gazes out from my eyes? The self is merely an idea encompassing everything about us, a fractal composed of all our sensations, emotions, and memories. The movement of this fractal through the synaptic channels of the brain is what we perceive as the first person. Our brain functions as a machine for understanding everything. The self is the name we assign to ourselves day in and day out. The self is, in reality, a multidimensional fractal of information. Humans are distinct from other living beings in that they have learned to speak and think in words, to count, and to imagine. Because of this, their ability to understand reality and themselves is unprecedented. Language is this understanding, embedded in the relationships between levels of meaning. It is language that allows humans to seek answers to questions like the one we posed at the beginning of this discussion. What is beauty? The most important contribution of language is that it makes us aware that questions exist in principle and that they can be asked. Without language, we simply wouldn't know that there is something around us to think about and talk about. Attributing oneself solely to one's genes, in the broad sense of one's biological makeup, is a limiting and thankless endeavor. If the self were to consist of a unique DNA sequence, within just a few generations, half of that uniqueness would disappear. In 2 generations, a quarter. In 3 generations, 1/8. Over a couple of hundred years, all remnants of personality would dissolve into the genetic river of the human species. In contrast, the structures that reside in words and numbers have the potential for immortality. It is these structures that help us recognize the amazing patterns in rivers, rainbows, shadows, spider webs, honeycombs, animal skins, in general, the world around us. To us, the world appears to consist of certain regularities that can be described mathematically. The ancient Greek philosophers were the first to attempt to describe and explain the order in nature, anticipating modern ideas. In his writings on the regularities of nature, Plato discussed the existence of universals around 400 BC. He posited that these universals consisted of ideal forms, and that physical objects are merely imperfect copies of these universals. For instance, a flower may appear roughly circular, but it will never be a perfect circle. Pythagoras regarded regularities in nature, much like harmony in music, as originating from numbers, the essence of all things. In mathematical terms, 0 represents nothingness, and 1 represents being, something. Empedocles, to some extent, anticipated Charles Darwin's evolutionary explanation of the structure of organisms. Empedocles envisioned the emergence of organic beings as a matter of chance, where parts came together randomly. Many of these accidental connections, heads without necks, torsos with eyes but no faces, human bodies with misplaced features, do not persist. This understanding, along with the assertion that less perfect creatures predated more perfect ones, from plants to animals, resembles the principles of natural selection and evolution. In 1202, Leonardo Fibonacci introduced the Fibonacci sequence of numbers to the Western world in his book, Liber Abaci. In 1917, Darcy Thompson published his seminal work on growth and form, in which he described the relationships of phyllotaxis, the arrangement of leaves on a plant stem, and Fibonacci numbers. The mathematical relationship of spiral growth patterns in plants has since become classical. Thompson demonstrated that simple equations could describe the seemingly complex patterns of spiral growth in animal horns and mollusk shells. Turing, Plato, Hegel, and Zeising, prominent figures in art and science, sought the strict laws of mathematics and found them in the beauty of nature. Spirals are prevalent among plants and certain animals, especially mollusks. For example, in the mollusk nautilus, each chamber of their shell is an approximate copy of the next, scaled by a constant and arranged in a logarithmic spiral. We observe the Fibonacci sequence in many places in nature. It begins with the numbers 1 and 1, and each subsequent number is obtained by adding the two preceding numbers. Hence, after 1 and 1, the next number is 2. 1 plus 1. The next number is 3. 1 plus 2. Then 5. 2 plus 3. And so on. Spirals in plants are evident in the arrangement of leaves on the stem, as well as in the structure of flower buds and seeds. For example, in sunflowers and pineapples. Many examples can be provided. The Fibonacci sequence and the golden ratio can also be seen in a pine cone, where numerous spirals are arranged both clockwise and counterclockwise. In terms of physics, spirals are configurations of energies that arise spontaneously through self-organizing processes in dynamic systems. Phyllotaxis is controlled by proteins that regulate the concentration of a plant hormone responsible for mid-stem growth, along with other mechanisms that determine the relative angle of buds to the stem. Biologically speaking, leaves are spaced as far apart as natural selection allows to maximize access to sunlight for photosynthesis. Within a plant's pattern, we can detect not only the golden ratio but also fractals. We find it remarkably easy to identify geometry in nature. Regular hexagons, in particular, are noteworthy. For instance, the honeycomb in which bees store their honey is a marvel of engineering and art, consisting of cells shaped as prisms with regular hexagons at their bases. The thickness of the wax walls is precisely defined. The cells are slightly angled from the horizontal to prevent viscous honey from leaking out. Moreover, the honeycomb remains in equilibrium, considering the influence of the Earth's magnetic field. This construction, achieved without blueprints, is built by numerous bees working simultaneously and coordinating the creation of identical honeycombs through swarm intelligence. If you approach bubbles on the water's surface and attempt to push them together, they will form hexagonal shapes, or at least come close to doing so. You will never see a cluster of square bubbles. Instead, they will immediately rearrange themselves into designs with 3 sides and roughly 120-degree angles between them. Why does this happen? Foam consists of numerous bubbles, and foams made from different materials exist in nature. Soap film-based foam obeys the Plato's laws, which require 3 soap films to join at 120 degrees and 4 faces to meet at each vertex of a tetrahedron at an angle of 109.5 degrees. The Plato's laws require films to be smooth and continuous, maintaining a constant average curvature at each point. For example, a film may remain nearly flat on average, curving in one direction, such as from left to right, and simultaneously curving in the opposite direction, such as top to bottom. Baron Kelvin formulated the problem of packing cells of the same volume in the most efficient way as a foam in 1887. His solution was a cubic honeycomb, with gently curved faces that satisfied Plato's laws. This solution remained the best until 1993, when Dennis Varon and Robert Fallon proposed the Vair-Fallon structure. This structure was later adapted for the facade of the Beijing National Aquatic Center, built for the 2008 Summer Olympics. This is an example of how people can be inspired by nature. Another of the most famous structures we observe in reality is fractals. A fractal is a self-similar, repeating shape. In other words, if you zoom in or out, you will see the same shape at every scale. These self-similar, cyclic mathematical constructs with fractal dimensionality are quite common, especially among plants. The most famous example is the fern. As you might realize, infinite repetition is impossible in nature. Therefore, all fractal patterns are only approximations. For example, the leaves of ferns and some umbrella plants exhibit self-similarity up to the 2nd, 3rd, or at most 4th level. Similar patterns to ferns are also found in many plants, such as broccoli, tree crowns, and plant leaves, and among animals, such as corals, hydroids, sea stars, and sea urchins. Fractal patterns also occur within us in the structure of branched blood vessels and bronchi. This strikingly beautiful, infinitely self-similar structure was discovered by the iconic Belgian mathematician Benoit B. Mandelbrot, who studied the structure of branched blood vessels and bronchi. Mandelbrot investigated recursive formulas with complex numbers. In his honor, fractals were named the Mandelbrot set. The Mandelbrot set consists of points C in the complex plane defined by an incredibly simple formula. By visualizing this formula on a computer and assigning each point a color, based on the number of iterations required to determine whether it belongs to the set, Benoit Mandelbrot produced an incredibly beautiful image. Fractals gained immense popularity with the advancement of computer technology, which allowed for the effective visualization of these structures. Consider that all this infinite beauty is poured into our consciousness from absolute zero. The Mandelbrot multiverse is akin to our own universe in miniature, the greatest complexity generated by an equally great simplicity. But what does the B in Benoit B. Mandelbrot stand for? The answer is Benoit B. Mandelbrot himself. From the very beginning of my immersion in the subject of beauty, the question has never left me: is there anything objectively beautiful? It was this question that compelled me to seek an answer. In one moment, the picture surrounding the phenomenon of beauty became clear to me. Initially, living matter perceives as beautiful everything that can aid its survival. That is, nutrients in some form, healthy sexual partners, bodies of water where one can always quench thirst, and trees where one can hide from predators. Almost from the very beginning, life began to develop a strong memory of what can help maintain its existence. Later in the course of evolution, in order to pass on its genes, it becomes existentially important for a living organism not just to find a mate but to actively attract one. Over time, peacocks developed brightly colored, conspicuous tails. Sexual dimorphism and the handicap principle compel evolution to explore new variations in the structure of living beings. Ancestral mammals, due to their nocturnal lifestyles, developed the ability to analyze the limited information they received. This, in turn, led to the accelerated development of the brain, specifically the prefrontal cortex, and the maturation of the cortex contributed to the complexity of consciousness. Living organisms gradually developed language and self-learning abilities. Within the framework of society, self-learning establishes motivations, determining what to desire, what to consider beautiful, and what to deem noble. Today, beauty encompasses not only the natural landscapes of pristine savannas with healthy partners, but also more abstract forms such as paintings, music, stories, texts, and actions. After this entire thought journey, I realized that beauty is a trust that we either possess or do not. Is it true that beauty is in the eye of the beholder? Is beauty truly subjective, or is it objective for all who might exist in our universe? Is it possible that completely different alien beings from a distant galaxy, whom we are unlikely to encounter throughout the entirety of our civilization, perceive beauty in the same way we do? It largely depends on how Earth-like their planet is. In a general sense, it depends on how similar their conditions of formation are to ours. If the origins and development of life on their planet are vastly different from ours, their evolution, culture, and concept of beauty will also differ. However, there is one unifying factor. We all inhabit the same universe. The common universe is what unites us. This will be the answer. In the early 1990s, German computer scientist Jürgen Schmidhuber presented an incredibly elegant and rigorous theory of mathematical beauty. According to this theory, people find complex objects with the lowest algorithmic complexity beautiful. This measure is also known as Kolmogorov complexity, named after the Soviet mathematician Andrei Kolmogorov, who first described it. The algorithmic complexity of a string of data is the smallest possible description needed to reproduce that string. For example, the following string has high algorithmic complexity because the shortest possible description of it is the string itself. In contrast, the next string has low algorithmic complexity because it can be succinctly described as repeating 32 times. The main idea of the theory of mathematical beauty can be expressed as follows. Beauty is complexity generated by simplicity. From this principle, it naturally follows that the most beautiful things in the universe must possess infinite complexity while being generated by incredible simplicity. In other words, everything emerges from nothing, everything from zero. During the height of Greek civilization in southern Italy, in a small town called Croton, the philosopher and mathematician Pythagoras founded his renowned school. In the Pythagorean school, the teaching of geometry was inextricably linked to the mystical interpretation of its figures, axioms, and theorems. The highest reverence among the Pythagoreans was given to the monad, a symbol of a circle encircling a brightly marked central point. The monad was considered a divine symbol, representing unity at the heart of all things and the origin of the world from the void. Loosely interpreting the views of the Pythagoreans, we can say that at the very beginning of the world, there was nothing, only zero. But since there was nothing, there were no limitations preventing the emergence and triumph of being, the unit. Thus, the nothingness lying at the very beginning of the universe explodes in all directions into an infinite number of logically possible variants. In the emergence of being, for everything, its opposite emerges. 1 always corresponds to -1. Perfect illustration of this cosmological myth is the figure of a circle, because its circumference contains an infinite number of points equidistant from the center, and for each of these points, there is an opposite point. The ancient Greek engineer Archimedes, who lived a few centuries after Pythagoras, spent most of his life in Sicily, not far from where the Pythagorean school was once located. There, Archimedes developed a method for calculating the ratio of a circle's circumference to its radius by inscribing and circumscribing increasingly complex polygons around the circle. This ratio, whose exact value Archimedes sought to determine, is what we now call the number pi. However, the term pi was popularized relatively recently by the outstanding German-Russian mathematician Leonhard Euler, who held a profound reverence for the circle, much like Pythagoras. Euler devoted a significant portion of his work to the study of the circle. While investigating the properties of sines and cosines on the complex plane, Euler discovered an elegant formula that, when incorporating the number pi, leads to an incredibly beautiful result. This equation, known as Euler's identity in his honor, is rightly considered the most beautiful formula in mathematics. It reveals a truly remarkable relationship between the 5 fundamental constants of mathematics: 0, 1, the base of the natural logarithm e, the number pi, and the imaginary unit I. It was as if all of mathematics and philosophy, nothingness, being, harmony, infinity, and unknowability, converged in this formula. The beauty of Euler's identity can be appreciated by any intelligent life form that exists in our universe, provided there is an adequate interpreter. The beauty of this encrypted story of the birth of everything is universal. Thank you for watching. Write in the comments what you think about the topic of the video. If you want to support my channel, the link is in the description.